We'll wait for some more people to join. Am I audible? Hello. Hello. Am I audible? Hopefully, people will join as we move forward. Okay. Then we go for this assignment problems, which we completed. Means week three assignment problem. Okay. You can interact it. I think now only one person is here. You can directly interact. Hello. Hello. Are you hearing or not? Hello. Is there any problem with the network or something?
No, sir. I have connected from two devices.
Okay. Okay. No. Is there any problem? From my side, there is no problem. No?
Pardon?
From my side, whether any problem?
Sir, on one device, speaker and um camera is not working. And
Okay. Okay.
another device is audible.
Okay. Okay. Nice. Okay. So okay. You can tell what are the. You can give some feedback. How the course is going on, and as the way we can start doing this assignment programs. How are you feeling this course?
It's good, sir.
What are you doing actually?
Pardon, sir?
What are you doing? You are a student or a teacher or something.
I'm student.
Okay. Doing what?
PhD.
BSc.
PhD.
PhD. Okay. Okay. Good. Where?
CSIR.
CSIR. Which lab?
Chandigarh.
Chandigarh. Okay. Good. Good. You can follow this course now.
Pardon, sir?
You can follow this course. There is no
Yes, sir.
much difficulty following this course.
No, sir, it's good.
Okay. You can solve assignments and other things. No problem for that.
Uh, yes, sir.
Okay. Okay. Let's start by doing this week three assignments. If you have any concern about that one, you can just tell. Okay. Anyway, hopefully people will join as we go on.
Yes, sir.
I'm going to share the screen. Is is my screen visible?
Yes.
Okay, nice. Hopefully you people may have did this assignments 3 and you may have seen the solution also.
Yes, sir.
Okay, 1 minute. Just give me 1 minute. ഹലോ. ആ, ഞാനൊരു NPTEL TA ഡ്യൂട്ടിയാണ്. അപ്പോൾ 6 മുതൽ 8 മണി വരെ TA ഡ്യൂട്ടിയാണ്. ആ, ഇന്ന് കൾച്ചറല്ല, ഞാൻ 8 മണിക്ക് ശേഷം വരും. ആ ആ. നാളെ എത്ര മണിക്ക് എടുക്കാനുള്ളത്? അത് അതിന് കണക്കായിട്ട് ഇന്ന് ഇട്ടാൽ മതി. ഒരു 12 മണിക്കൂർ ഗ്രോത്ത് വേണം. അപ്പം 9:30 ഇട്ടാലും മതിയാവും. 9:30. ആ ആ ആ, പ്രശ്നമൊന്നുമില്ലല്ലോ. 9:30 വരുന്നെങ്കിൽ. ഇല്ലെങ്കിൽ ഞാനങ്ങ് ഇട്ട് വെക്കാം, പ്രശ്നമൊന്നുമില്ല. ആ ആ ആ. ഇല്ല ഇല്ല, നമ്മളവിടെ വരുന്നതിന് കുഴപ്പമൊന്നുമില്ല. നമ്മള് 9:30 ഒന്നും നമ്മളെ സമയമല്ല ആക്ച്വലി. ആ ആ, ശരി. ഓക്കെ ഓക്കെ, ലെറ്റ്സ് സ്റ്റാർട്ട്. You people are seeing the screen now?
Yes, sir.
Okay. You people already knowing this. You people did this assignments
Yes, sir.
and all got a right answer. How was the answer? Everybody got a right answer, or you have some confusion regarding these answers, or how to do this one? Hmm? Now, actually, I cannot see my screen, so it will be better that I get some feedback such that I can see that okay, I am talking to some people.
I have a doubt, sir, so it will be good if you can explain
Okay.
this one.
For doing this one, you have some problem. This question, or it's a new
Yeah,
doubt.
yeah, it will be good if you could explain this.
Okay, okay, okay. So let us start with this question. So we can go on, and in between, feel free to stop me and ask any clarity required. Okay, such that I don't. I want to people to be clear when we are moving from this question to another question. So this almost like yeah, I saw this questions like almost all question is based on this single setup itself. So yeah, if you could understand everything, I think still fifth or sixth question is can be answered. Okay, so let us see about this system. So see, for an optical system shown in this figure, the focal lengths of the lenses L1, L2 are 1 centimeter and 2 centimeter respectively. The height of the lens is 3 centimeter each, and the height of A1 aperture and A2 aperture is 1 centimeter each, and all the distance are given in centimeter. So they have given a lens system containing of 2 lenses and 3 apertures. Apertures means just an opening, you can say. So this is a system containing 2 lenses and 3 aperture. Now, based on this system, and all the scales are in centimeter, and lenses have some certain diameter, apertures have some certain diameter of the openings, and these systems are arranged in a particular distant fashion. So, and it is forming an image of an object. Now, see, it can be like a camera or anything, some imaging system. So, this is the system which is given. Now, now we have to find. So first, go through the system and see the element that act as the aperture stop of the system. Second question is like location of the entrance people of the system. Next, the diameter of the entrance people and the diameter of the exit people, and based on that, how it is giving rise and other things. Okay, so let us recreate the system and find which is the aperture stop, which is entrance people, which is exit people, like that. Let's see. Now I'm going to redraw the system. So first I will draw an optical axis. And it contains two lenses. I draw two lines such that, and then just these are thin lenses. Okay, and it also has two aperture stops, two apertures. And there is an objective here. It's an objective, and we have given objective to first, and this is written like A1, A2, this is L1, L2, and it has a focal length of 1 centimeter. It has a focal length of, I write it as F1. F2 has a F2 has diameter focal length of 2 centimeter. And the distance between this object to first aperture stop is 4 centimeter, and aperture to lens is 2 centimeter. From here to here is 3 centimeter. Here to here is 3 centimeter, and the diameter of the lens system is 3 centimeter, and the height of the aperture stop is aperture here 1 centimeter. Okay, this is the system. Anybody have doubt that why we putting this thing like to some capacitor kind of thing here? What is the original shape of this one? How it will be look like if you took it in a hand on aperture? How it will be look like? Any idea? Mm-hmm.
It it will be so circular, like in fronts of camera.
Yeah,
We have multiple shutter types.
yeah. If you took it in an aperture, sorry, it will be some shape, let it be some square shape or anything, some opaque body, and middle portion there will be an opening, and this opening diameter only we are saying about. This is the one. This is the diameter. This all portion will be opaque, and only this portion will pass the light. So this opening is the aperture, and its diameter is actually, what will be the diameter of this aperture? You can see here the radius they are given 1 centimeter. So radius is 1 centimeter, means
Two.
diameter will be 2 centimeter. These are like a some shutter, or shutter I cannot say, some opaque screen which is containing a 2 centimeter diameter hole in front of that one. So just to show the opening. So this portion will not, light will not pass through this one, only light will pass through this one. We are actually showing the hole. This will be the hole opening kind of thing. This will be like some opening here. These are the things. Okay, only light will pass through this way. It cannot go through beyond that hole area. This is actually the thing. Now now we can, from here actually, what is the first question? What is the what is the aperture stop? What is actually mean by aperture stop? What is actually aperture stop? Aperture
Uh,
stop. Yeah.
that area
uh,
which restricts the light,
uh,
incoming light on which the whole system is based upon.
yeah. Aperture stop is the element which restricts or which limits the whole amount of the light which enters from objective to that system. So you can see that there are a lot of elements. You can see that there is a A1. A1 is a particular aperture having a diameter. And next element is a lens. Lens is also a aperture with power having a particular diameter. Then there is an A2 aperture which is having a diameter. And there is a F2, another lens having a particular power, means a particular focal length and a particular diameter. So one of the lens or one of the aperture can act as the aperture stop, means which is actually restricting the light which passes through the system. It can be either A1, or it can be L1 or A2 or L2. Now it is our idea to find out which is actually aperture stop. So how we will find out? What is the method we have to find out aperture stop? How we will find out? So we have some terms based on the aperture stop. We have some terms. What are the things? One is aperture stop itself, and we have
Uh,
axial ray or marginal ray.
Principal ray, chief ray.
Yeah.
We have to
So
see the area which is taking by this ray.
yes. So based on what will be the much useful rays to determine aperture stop? Chief ray or marginal ray? Axial ray or chief ray? Which will be much more useful?
Axial ray.
Yeah. Axial ray will be much useful. Now just think a single lens system. I'm saying that there's a single lens system. Now just think that there is only single lens system, and I have a object, a point object here. Now, which is aperture stop here? What is actually limiting the amount of light reaching through the system? What is the amount? What is the thing which is limiting the light to reach the system? This is an object point. It will produce a lot of light now. It can produce light which is going this direction, this direction, this direction, this direction, this direction. Just think that it's an illuminating object. So light can reach in every direction. What is the light which limits to pass through this optical system?
Lenses itself.
Lens itself. Precisely, lens, what property?
Uh, Pardon?
Lens, which property is actually limiting that amount of light?
Refractive index.
That's
Uh,
okay. Now I am saying that I am changing a lens refractive index to another refractive index. Whether that will take more light in this side?
it depends upon the medium, like whether it will have a lesser refractive index or a more, and then there will be TIR or not.
Ah, that's okay. Just now think that the lens is a very thin lens. Whatever the light it is coming here, it will refract. That's an
Yes.
ideal system. So, but there is another thing, which is actually,
Angle.
which
Uh,
angle?
and field of view,
Field of view will be some more precise term. Now you can see that, yeah, field of view you can say, yeah, field of view of the system,
or
yeah,
we can say tan omega,
yeah. And now we see
collection angle.
only this much light only can pass through the system, correct now? Because if the light is not reaching at the lens, it is lost. It is not at all pass through this optical system, correct? So if you want more light to be passed through the system, what you have to do? You can use a lens having the same properties but having some more long time,
Dia,
yeah,
bigger dia.
bigger diameter you can use now. Then it will collect more light. So even a lens can itself act as a aperture stop. Okay. Now that if there is nothing is there, even the lens diameter can act as an aperture stop. Now just think that this is the same lens, but I have a some opening here. What will happen? Whether in initial time this much light is passed through the system. Now whether that whole light can pass through there?
Now the restricted part will decide the aperture stroke.
Yeah. Now see, only this portion is passing. So here, what is restricting here? This opening is restricting the amount of light entering to the system. So initial previous time the lens was the aperture stop. Now what is the aperture stop? Now this aperture is aperture stop. Okay. Now just think another condition. This lens has a focal length of some 10 centimeter. Okay. So 10 centimeter is focal length, and here I have an aperture stop or aperture, I put it here. So what happens? All the light reached here will focus here. whether this aperture is restricting this light reaching here. This aperture A. This is an aperture A. Whether this aperture is restricting any light to reach here.
No.
In this case, what is the aperture stop?
The lens.
Yeah, here the lens itself is aperture stop. So an aperture can be or cannot be aperture stop, or a lens can be or cannot be aperture stop.
Right.
Everything is depends on what is the amount of angle which is actually passes through the system is determined. When the angle is increasing means more light is passing through. When the angle is
Right.
less means so less light is passes through the system. So if we could find out that angle somehow, we can determine the aperture stop. Okay.
Right, sir.
So based on that one, we are going to find out the aperture stop of the system. So now we will see that what are the angles made by this A1, this L1, A2, L2, and find out and what will be the aperture stop, which is the element which is producing the least angle. Okay. So if the lens can produce a bigger angle, but you just think that if there is an aperture here and this is the one which is restricting the light, if the it's a particular aperture which is restricting the light to this one, this will produce a small angle, correct? And this will be act as a aperture stop. So which is the element which is producing a least angle will determine which is the aperture stop element. So we are going to find out that one here. Okay, now see, let us find out if a1 is the element, means this aperture will make how much angle. Okay, now just think that one light is passes through this thing. In that case, I want to find out what is this angle theta 1. I will tell. How will find out the theta 1 here? I know the size of this. Now this is a right angle triangle, correct? And I know this side 1 centimeter. I know this length already given 4 centimeter. So what will be theta 1? So I am going to find what is the parameters produced by A1. I want to find just think. Now there is a theta 1 I have to find out. Okay. So how will I find out? This is a right angle triangle having one perpendicular side of 1 centimeter and the base of 4 centimeter. So if you know the opposite side and adjacent side, you can get the angle. What is the formula? Tan theta 1 will be equal to 1 by 4. Correct? Any doubt? This implies theta 1 will be equal to tan inverse 1 by 4. What will be the answer? You will get around 14.03 degree. Okay? Any doubt? If light is passes through that aperture, it will produce an angle of 14.03 degree. Understood? No doubt, na? No, I'm not hearing any voice. I'm not seeing anything also. So
No, sir. No, sir.
Yeah.
Clear, clear.
Now let us go to the, just think that if L1, if L1 is the one which is producing angle, let us see that how much angle the lens will produce if there is no aperture here, because these are just the opening. We don't know whether this will block the ray or not. Now just assume that if there is nothing here to block here, now see what will be the angle produced by the lens. Okay, now second portion we are thinking about L1. Now see, now what is the triangle which I have to consider? I can consider a bigger triangle. Okay, this is the other triangle. If there is no A1 is here, or if A1 effect is not at all there, it should be, let us see. Now please tell that what is the parameter of this triangle? This is a right triangle, and what will be the base length? 4 plus 2, so it will be like 6 centimeter base length. And what is the height? Height already defined, the lens's heights are, or lens radius is 3 centimeter. So we have theta 2. So I'll say that tan theta 2 will be equal to 3 by 6. Correct? Tan theta 2 will be equal to 3 by 6, implies theta 2 will be tan inverse 3 by 6, or tan inverse 1 by 2. That will be equal to 26.56 degree. Okay, any doubt? 26.56 degree. Now by seeing that two things itself, we can directly say tan theta 1 is equal to 14.03, tan theta 2, or theta 2 is equal to 26.56 degree. This lens is making a bigger angle compared with this aperture. So definitely lens is not the aperture stop, because the aperture is making only 14 degree angle, lens is making 26.56 degree angle. So this aperture is only making 14 degree, the remaining portion is actually blocked. So lens is not the, this L1 is not the one which is going to be an aperture stop. That you can definitely see now. Correct? Any doubt?
Yes, so that is quite apparent by visual inspection itself.
Yeah. But yeah, the thing is that by seeing itself, we can see that one. But now you have to see whether aperture 2 is making any particular, whether aperture 2 is the one, whether it is making or blocking the
So
light.
can you tell the last one that 14.03 is less than 26.56?
Yeah.
So which one will be a purchase?
If you are considering A1 and L1, A1 will be aperture stop. But we have still elements here. A2, L2 are still here. We didn't calculated all other things.
Sir, in these two, A1 will be a purchase stop.
Yeah, if you don't have all other system, then A1 will be aperture stop. Why? this angle will be 14, and this big angle will be 26, because if light is passing after 14, light cannot pass and reach 26. We just calculated thinking that there is nothing to stop here, then you got 26. But after 14, what will happen? All the other things will be stopped by this aperture. So
Okay, lesser one we have to take
yeah,
because it will stop more.
yeah, okay,
Okay.
yeah. Now this was simple, because we can directly see that if there is no problem with if A1 is not stopping, we got it will be 26, but now got that A1 is giving 14 degree, so apparently A1 is going to be aperture stop. Now the complicated system is coming. Now whether we have to see whether A2 can be aperture stop or not. Now this is a somewhat tricky. So A2 is not the one which is directly making angle with the object point, because the light is reaching A2 only passing through this L1 lens. Okay, and the L1 lens have a particular power. So the light reaching A2 will not be like what we drawn previously. Like light cannot directly reach L2. Light will reach lens and it is bends and reaching A2. So if you are looking, just think that you are looking from this direction. Just think that you are looking from this direction and you are seeing A2. What actually you are seeing, whether you are seeing A2 or an image of the A2. If you are looking, if you are a person, you are just standing here and looking, what you will see, whether you will see A2 directly or an image of A2 with this lens, what you will see. Got it?
Image.
Yeah, what you are going to see is an image of A2, and that particular image is called, if that's an aperture stop, that particular image is called entrance pupil. Okay, if that's an aperture stop only. Anyway, you are seeing through a lens, so whatever you are going to see is a image of A2 only. So we have to determine if A2 is going to be an aperture stop, then we have to see whether the image of A2 is producing what is the angle. Got it? Any doubt for that one?
No,
You have doubt?
no doubt.
Okay. Now, so first we have to see where will be the image of A2. Okay. Now you can see that this is a lens. You don't have a problem with the drawing inside this one, na? You people can understand whether I have to draw a new image.
No, sir.
This is okay.
Yes, sir.
Okay. So just think that this is A2. Oh, it is better. I remove these things. Now I want to see where will be the image of A2. So just think in the opposite manner. This is A2. How, how much distance A2 from this lens? It's already given 3 centimeter. So I can say 3, 4. I am seeing A2. Calculation is not over. I am saying that object distance. What's object distance? A2 to this lens. How much? Will be 3 centimeter. Okay, 3 centimeter. Now focus. Focal length of the lens f1 is given 1 centimeter. Now I want to see where will be the image. So I have the equation like 1 by u plus 1 by v is equal to 1 by f. Now, okay, tell.
So can you use this explaining sign conventions? It makes bit of puzzle.
Yeah, that I am making. Now you see, I am following the sign convention, making you easier. Okay, this is the same. You can use the same equation 1 by u plus 1 by v is equal to 1 by f. The thing is that if you can put a logic here, you don't have to think much about this one. Okay, now you are seeing this thing na here. This one you are seeing. What you want to
Yes.
what you want to see now. Now you have a lens here and you have an objective at having a height of 1 centimeter here, and lens have a focal length of 1 centimeter. It is at a distance of 3 centimeter. Now you want to find where the image is. Okay, okay, this is the construct na. This is the way you have to solve, but this is actually opposite of your original thing, because whenever we are solving, we will always solve our object is left side. So just think that you are looking at this direction, or just think the other way. This is the equivalent as now I am putting a same thing 3 centimeter. Okay, if a light is coming from this direction to this direction, or if the light is coming from this direction, it will be same only na. This is
Yes.
this is equivalent to this one. One is you are looking from this side, another is you are looking from this side. Correct na?
But in our case, the objective was placed
Right,
before 4 point, na?
means this is your objective. A2 is your objective, and this is your lens L1, similar as this one. See, this is your objective. It's at a
This is
distance.
image, na?
Yeah, this is you are thinking as image, but you see in this, see, you are looking from this side. You
Yes.
are, yeah, your object is this one, and you are going to see where will be your images. So in usual lens, from where you are looking, your object is this side, and you are looking image in this side. This is your normal thing, but here actually it is in the ulta way. Got it?
Yes.
Yeah, so I am making, in order to avoid putting extra signs, I'm just looking in another way. Now you see 1 centimeter at one side. This is here. Yeah. Now this and this are equivalent only now. If an object is kept at a 1 centimeter object is kept at a lens from 3 centimeter. This is the similar, but here only the problem is that light is coming from right to left. But the usual convention, it is coming from left to right. Okay. So I am going to solve this this easier thing, and I will interpret how it is going to be image will be here. Okay.
Okay. In the question, the objective was placed on the extreme left.
I am not saying about that object. I am saying this
Uh,
A2.
But we are taking the image of the object as an object on the aperture plane.
Ah, why we are taking that one? Now see. Now see this one. Now just think that this is your lens. This is your lens, and just think that this is your aperture. Now the thing is that your lens has a bigger focal length. It is going like this way. What happens if this aperture stop is not here? What will happen? This lens will focus like this way.
Yes.
Okay, but what happened here? Here there is an aperture stop is here.
Yes.
So all light will not reach here. Only certain amount of light which is in this portion only reach the focal.
Yes.
In this case, because of this one, your second thing became aperture stop.
Yes.
So even though a lot of light reached till your lens's edge, that is not useful. So only this much light is actually passing through the system.
Yes.
Now see. So but what you are going to see, just think that you are looking from here. If you are if your eye is here, if you are looking at from here, what you are going to see, you will see the light is reaching here towards your eyes.
Okay.
You don't know that from where this light is coming, because the light, you are thinking that which direction your light is coming from, where you will see that light is coming from some big portion, and you will feel that it is coming from some directly from this side. But actually what is happening, light is coming from here, it is bending here and reaching your eyes, but your eye will feel that there is some bigger thing is in the other side, from there light is directly coming. So whatever your eye is seeing a image of this aperture stop, you will feel that some big thing is there, some big opening is there, from there light is directly coming towards your eyes, but that's actually image of your aperture stop. Now we want to find what is that one. Got it?
Okay.
So in that case, actually what you are going to find, the image of your aperture stop, because actually light is coming here and it's bending and reaching your eyes, but you feel that it is coming from somewhere. This is actually not an exact image, we have to find out. But in this case, maybe it is, you will feel that it is coming from some bigger position, and that position you are calling as a entrance pupil. So you will not see that light is bending. Whenever light is reaching your eye, you will feel that it is coming straight line. Even though if it's bent, you will think that it is coming from some big opening. And that
Okay.
position is called entrance pupil. Now we are going to find out that one. So in that case, your object is like A2, this one. And you are going to find out what will be the image of A2, where it will be you want to see. Okay, so now A2 is your object. We want to see where is the image of it. So A2 is actually 3 centimeter right side of your lens, and you want to see the image of that one, where it will form. So if you're in normal convention, what we used to do, always we used to put your object at the left side, and the image will form somewhere, and based on that direction we will find out where the image is. So
Okay.
so now I am putting exactly same thing equivalent to your system, but what I did, it's like a mirror image of the system. So I put that object at left side, 3 centimeter left of that one, and I am going to find out where the image will be formed. This thing you can solve now. You have
Yes, sir.
u is equal to 3 centimeter, f we know, f is equal to 1 centimeter, v we don't know. So we have the equation 1 by u plus 1 by v is equal to 1 by f. 1 by v will be 1 by f minus 1 by u. So 1 by f will be 1 by 1 minus 1 by u, 1 by 3. So what will be the answer? 1 by 1 minus 1 by 3 means 1 minus 1 by 3 is equal to 2 by 3, or b is equal to 3 by 2. So v is equal to 1.5 centimeter. Got? So v is a positive. So in this case, actually what we solved is here. So if an object is placed 3 centimeter away from the lens, image will be formed at 1.5 centimeter after the length. Correct? Here will be your image. Got it? Any doubt?
No.
Yeah. If the object is at the left side, image will be formed at the right side. Now see this system. Object is at the right side. So where the image will be formed? Image will be at a
Left side.
left side, at a distance of 1.5 centimeter from the lens. Correct? Now see your system. This is your 1 centimeter, and object is at 3 centimeter. So image will be formed somewhere at 1.5 centimeter away from the lens, and this distance will be 1.5 centimeter. This is the position where your image of this A2 is going to be formed. And now we want to see what will be the size of that one. Now we only see that, okay, somewhere in this plane the image of A2 is going to be formed. Okay, now we want to see what will be the size of the image. For also you will use the same trick. Here we have magnification is equal to we have magnification m is equal to minus v by u, and what will be here? Minus v 1.5 by u, 3 centimeter. 1.5 by 3, how much? It will be minus 1 by 2. Okay, so magnification is minus 1 by 2. The thing is that the top portion will be bottom, bottom portion will be top, like that way. The image will be smaller and 1 by 2. Now you see what will be the size of your image. So magnification, we already know that m is equal to height of image divided by height of object. So, and I know that height of image, that I don't know, divided by height of object I know, so 1 centimeter is equal to minus 1 by 2, or height of image is equal to minus 1 by 2 into 1, it will be minus 1 by 2 1. Now you see, if a particular object is here, its image will be inverted and its height will be half centimeter. Now, but this object is a what kind of object? This object is an aperture and it is a completely symmetric here. So, what kind of image you will get here? This portion will be here, this portion will be here, and you will get another circle which have a smaller diameter. What? Any doubt? Hello?
No.
Yeah. So, but this is actually ulta. Object is, but here, so you will get a image having a smaller diameter here, and this is 1 centimeter. This will be like a 0.5 centimeter thing here. This will be the image of A2. Got? See? So what is actually happening here? Light is actually coming from this one only. Just light is coming from this one such a way that it is coming from here. Sorry. So, yeah, this portion will come here. Yeah, light is coming from sorry. Light is coming from this portion such that this passes through this aperture stop. Maybe it will go like this way or go like this way, such that we will feel light is coming from here. It will touch this aperture stop only. Light will be passing from aperture stop only, but it is appears to be coming from this image of this aperture stop. Okay, original aperture stop is here. The aperture stop will produce an image of the aperture stop at in front of the lens, not aperture stop. I will not tell aperture stop. That aperture will produce an image of your aperture here, such that it is a light is coming from this portion. Okay, got it? Hello?
Yes.
So your original aperture is here. This is your original aperture, this big one. but it will produce a small image of the aperture here, this red one, such that the cone of light will be passing through this one only. Okay, and this, and actually this will produce a big cone of light here. But the thing is that whatever the light is coming from this cone is actually controlled by this aperture. But the thing is that we will feel like light is coming from this small cone only. Got it? Got? Any doubt? Okay. Now we want to find out what is the angle produced by this small image. Now you see. Now this is a right angle triangle. What is the hypotenuse? This is 0.5. You can see. I am going to draw the same thing here. The size is 0.5. 0.5 here. And this theta I want to see. Theta 3 I will put. And what is the distance here? Now I saw that this is a 1.5. This distance is 1.5. You already told, na? And this entire distance is a 4 plus 2, 6. And but it is actually 1.5 centimeter from the lens. So this distance will be 6 minus 1.5. Correct? This distance. Okay? Any doubt? Any doubt for that one? Okay. So what will be the answer? So if I go for this one, I got 1.5 centimeter here. So, and the height of that one also I find out it's 0.5. So I got a triangle. It's a theta 3 will be tan inverse 0.5 divided by 6 minus 1.5. It will be how much? Tan inverse 0.5 divided by 4.5 is equal to 6.34 degree. Okay. Now we see that first one is producing an angle of 14 degree. Second one is producing an angle of 26.56 degree. And aperture 2. This one, even though this one is looking like big here, since there is a lens in between here, it is producing an angle of how much? 6.34 degree, which is the least one among the three. Which is a 6.34. Now you got, na, here also you can obviously see that even though this big aperture A1 is here, even though if A1 is here, light is not at all touching there. This is the second one. Big lens is here, but light is not at all reaching the edge of the lens. But light is reaching at the A2. But it is producing a smaller angle in front of the lens. So now among this A1 and L1, A2, which is going to be the aperture stop? A2 is going to be the aperture stop because it is producing a angle of 6.34 degree only. Correct?
Yes.
Okay. Now we have one more element. which is the element. One more lens is there, L2. Sometimes this can be your aperture stop. Now we will see. If there's a lens is here and if you are looking at this direction, what you will see? You will see image of this lens through L1. Correct? You are going to see, just see that how will we see if you are looking at from the object. So if you are looking at the object, you will see image of your lens L2 through the lens L1. That will determine whether our L2 is a aperture stop or not. Okay, now we see. Now we can see that what is the distance from this L2. Now consider L2 as an object. What is the distance from the object to the lens? Here there is a 3 centimeter, then one more 3 centimeter. So what is the total distance from L2 as an object from L1? Similar thing we will use here. So what is the distance from here to here? Now this 3 centimeter is not the length. Now I will draw more. This is the condition. My second lens is here actually. This is my second lens, but I don't considering it as a lens. I am just considering it as an object. Now what is the distance here? Say 6 centimeter. And what's the height of the lens? Say 3 centimeter. Now I want to see where will be the image. Okay. Now, but it is not easy to calculate from, if you want to put your sign convention, your object is at the right side, then you have to put negative sign, and your focus is going to be left side, again you have to put it a negative sign. So easier thing is like that way, you can just consider in the other side. You consider in such a way that I will say this is the ulta side. My object is at 3 centimeter height object at 6 centimeter away from my lens, and the lens focal length is f is already given 2 centimeter. So I want to find out the image, where is the position of my image. So I have the equation 1 by u plus 1 by v is equal to 1 by f. So u is equal to 6 centimeters. So 1 by 6 plus 1 by v is equal to 1 by 2. Implies 1 by v is equal to 1 by 2 minus 1 by 6. What is the answer? 6 minus 2 divided by 12. Sorry. What only that? Yeah. No. Sorry. 1 by f is equal to focal length of lens 1. This is 1 only. I'm going to make a mistake. So u is equal to 6 centimeter. V we don't know. f is equal to 1 centimeter. Okay, so 1 by u plus 1 by v is equal to 1 by f 1 by 6 plus 1 by v is equal to 1 1 by 1 is equal to 1. So 1 by v is equal to 1 minus 1 by 6. What is the answer? 1 minus 1 by 6 is equal to, people are hearing now?
Yes.
Yeah, okay. 1 minus 1 by 6 is equal to
5 by 6.
5 by 6. So v is equal to 6 by 5 is equal to 1.2 centimeter. So we have, if there's a lens here and the object is at some 6 centimeter here and having a, this is our object, 3 centimeter height. And 3 centimeter height, then it will form at a, some image will be at a 1.2 centimeter. Okay, now we want to see how the image is going to be formed. What is the size of the image? So we have magnification m is equal to minus v by u is equal to minus 1.2 divided by 6. Minus 1.2 divided by 6 will be 0.2 na? Yeah, minus 0.2. Now I have that same as that will be equal to height of image divided by height of object. That I know, height of image I don't know. Height of image divided by height of object is know 3 centimeter is equal to minus 0.2. So I will get height of image is equal to minus 0.2 into 3 minus 0.6. So if there is a 3 centimeter object, you will have an image of some 0.6. Got it? Now see that this 3 centimeter is not at all an just one object. It is an aperture of 3 centimeter height. So what you will have here, this side you will have a aperture of image of the aperture of 0.6 centimeter radius. Got it? So now if the object is at 6 centimeter left, image will be at 1.2 centimeter right. Now but here actually the ulta. Object is at 6 centimeter right. So your image will be at 1.2 centimeter left. Okay, this is actually 1.5 centimeter. I think you remember that. So this will be something, the image will be something like here. 1.2 centimeter left. And what is the height of the image? That you just to find out here. Height of the image is 0.6. And this was like 0.5. And this height of the image is 0.6 here. Okay, now we have again one more triangle here. So 0.6 size height. What is the distance? So total is equal to 4 plus 2, 6. Then this height will be 6 minus 1.2. Correct? Because this is actually 1.2, this distance. Small 1.2 distance from the lens. Correct? Any doubt? Any doubt for this one? That's triangle. Hmm? Any doubt for this triangle? Whether I have to redraw that one? You can tell if you want. I will draw. Hmm? If you have confusion for that one, just tell. I will draw. So here you have your lens here. This is your L1. You are not considering here. This L2 is here. L2 was like a 3 centimeter here, and it is producing a image of L1 around and having a height of 0.6 centimeter here, and at a distance of 1.2 centimeter from the lens, and your object is at this is your object point, and your object is at 6 centimeter from the lens. So now you are making a triangle here. This is the triangle you are checking. So this is a triangle which have a height of 0.6, and this is a total 6 centimeter. See, this is 4 centimeter plus this 2 centimeter, and out of which 1.2 centimeter is taken by that image. So this will be 6 minus 1.2, this distance. So 6 minus 1.2 is like 4.8. Okay. So what will happen here? What is the angle here? Theta. And theta is equal to 0.6 by 4.8. It will be equal to, or implies theta is equal to tan inverse 0.6 by 4.8. It will give around 7.125 degree. Got it? So L2 theta 4 is equal to 7.12 degree. Got it? Any doubt? Any doubt?
No.
Now you see A1, this first thing is making an angle of 14 degree. L1 is making an angle of 26.56 degree. A2 making an angle of 6.34 degree. L2 making an angle of 7.12 degree, which is the least angle. Which is the least angle?
6.3.
6.34 degree, which is actually producing the image of A2. Correct? Correct?
Yes.
Yeah. So image of A2 is producing an angle of 6.34 degree, which is the least angle. So which will be the aperture stop here? Which is going to, yeah. So A2 is going to be the aperture stop. Okay. Now you actually don't need to worry. You might think that okay, after doing so much thing, actually you only reached your first question. Correct? Correct? Or you're feeling like that way? You did almost like 1.5 hour calculation and you only reached Answer of first question only. The element that act as the aperture stop of the system is, which is the answer? A2. It's already given. Accepted answer is A2. Correct? But actually, what we did all the things. Now we can go through the questions and see. The location of the entrance pupil of the system is dash centimeter from the object. What is meant by the entrance pupil? What is meant by the entrance pupil? Entrance pupil is the image of the aperture stop by all the element preceding that element, preceding the aperture stop. Okay? Entrance pupil is the image of the aperture stop formed by the elements preceding to the aperture stop. So, see, we already drawn this one. This is A2 is the our aperture stop. Where is our entrance pupil? This is the image of the aperture stop. Correct? This red one. Okay? This red one is going to be the image of the aperture stop. So that is actually the entrance pupil. Got it? And we already know that what is the distance between this one to here. That is we already written here as 1.5 centimeter. This distance. 1.5 centimeter. Correct? So what is the distance from object to the entrance pupil? That also we already calculated here. This is the total distance is 6 centimeter minus this distance 1.5. 6 minus 1.5. How much? How much? How much? Do you have confusion? You can tell clearly. You can tell. I will explain. You are hearing, no?
Sorry, can you tell entrance pupil again?
What?
Definition of entrance pupil.
Definition of entrance pupil is the image of aperture stop by all the elements preceding it. So now this is your system. Now our system is very complicated looking. Now we already know that this is our system. It has two lenses and it has two aperture here. There's aperture here. There's some aperture here. There's some aperture here. Now see, now already we find out your A2 is the aperture stop. So what?
Yes.
So where came the image of this aperture stop? That also we found out that it is came somewhere. This is your object, and object is at 4 centimeter from this aperture, and there is a 2 centimeter distance here. This is 2 centimeter. And we find out that image is coming like around 1.5 centimeter, and that size was 0.5. That's the thing which we see here. See here, this red one. So what it will create? It will create a small image of your aperture stop at 1 centimeter, such that you will feel the light is actually passing through this way only. This is the one which is came. Correct? Such that light will pass through something. some cone of light will be formed like this way. Okay.
Yes.
Now you see. So this is actually the image of your aperture stop. Okay. And this red portion is called entrance pupil. Actually, there is no point here. But the thing is that light is actually eliminated by this point only. If it is coming somewhere beyond this one, light will not pass. Beyond this one, light will not pass. Beyond this one, light will not pass. If it is coming like this way, light will not pass. Light will not pass. But the thing is that like that way, in order to reach here, only light has to go from this cone only. If some light came somewhere higher here, it will reach here, but it will cut out. Only the cone of light which is reaching in this portion will only pass. So even though your aperture stop is here, image of the aperture stop is the one which is actually determines the cone of the light which is passing through the system.
Okay.
And that position is called, now it's like there is not a real aperture stop there, but this original aperture stop make a small image of the aperture stop in front of your lens such that it is only that amount of light which is passes through that area only reaching the optical system. So that portion is called entrance pupil.
Okay.
Now see that what is the distance from your object to entrance pupil. This is 1.5 centimeter away from the lens. The total distance is 6. 4 plus 2, 6. So what is the distance from here to here? This will be like total is 6 and this portion is 1.5. So this portion will be 6 minus 1.5, that will be 4.5. Correct?
Yes.
This answer is correct. Now see, next question. Diameter of the entrance pupil of the system. That already we find out. See, what is the size of this height we already find out. What was the size? This size,
Point.
0.5. But that is not the diameter. That's only the radius. So your diameter of the entrance pupil will be, this will be this much diameter. What will be how much? 0.5 into 2. How much? 0.5 into 2. Actual answer is diameter of the entrance pupil will be 1 centimeter. Okay. Now, diameter of the exit pupil of the system. That you have to do extra. Diameter of the exit pupil. So, similar way we have to do other. But the thing is that that is somewhat easier. Now we already know the what is the aperture stop here. So A2 is the aperture stop. So exit pupil is the image of aperture stop formed by all the elements after the aperture stop or after that particular thing. Now we already know that A2 is the aperture stop. Now you have to see image of A2 given by the elements after that one. What is the element after that one? A2. There is only one element. What is that element? What is the element? Hmm?
L2.
L2. So the question is simple. Find out the size of image produced by an object having 1 centimeter height kept at 3 centimeter from a lens. That's the question. So that you can do easily. You can do here. So you have a lens L2 here, and you have a object. This is your aperture stop having a size of 1 centimeter, and that's at a distance of this 3 centimeter. 3 centimeter from the object lens L2. L2 having a f2 of I think 2 centimeter. Okay. So 2 centimeter. Now can we find the size of this image? So in order to find out the size of the image, I want magnification. In order to find out the magnification of the image, I want the image distance. So I have our equation 1 by u plus 1 by v is equal to 1 by f. What is u? 1 by L. What is u? Object distance. 1 by 3
3.
plus 1 by v is equal to 1 by f. F is given 2 centimeter. So 1 by 2. So 1 by v is equal to 1 by 2 minus 1 by 3 will be equal to 3 minus 2 divided by 2 into 3. 6 implies v is equal to 6 by 3 minus 2. 3 minus 2, 1. So v will be equal to 6 centimeter. So your image will be formed something after 6 centimeter. But now you see what is the magnification? M is equal to minus v by u is equal to minus 6 by u is equal to 3. Magnification will be minus 2. Now I know the size of my object. It's 1 centimeter. So I have height of image divided by height of object is equal to magnification is equal to minus 2, or height of image is equal to minus 2 into height of object is equal to minus 2 into height of object is equal to 1 centimeter is equal to minus 2 centimeter. That means that this is like a, if the 1 centimeter is here, then the image size will be something minus 2 centimeter. But I have a, this is like an aperture. It's a 1 centimeter big hole. So here we will have an opening of 2 centimeter here. So what will be diameter of your, and this thing is, this image is called a exit view. What is the diameter of this one? What will be this diameter?
4.
Will be 4 centimeter. Got it. See what is the, yeah, the diameter of the exit pupil of the system is 4 centimeter. So by seeing one answer, yeah, to find out the answer will be a little bit difficult, but once you started find out the answer, then everything is a direct thing. Okay, which of the following correct for the case of the chief ray in a typical imaging system? What is the chief ray? What is the chief ray? Chief ray is the ray which passes, or the ray which is coming at the edges of the system, and it passes through where it is passes through. The ray which is passes through, whether it is touching the edges of your aperture stop or something. What is marginal ray or axial ray? Axial ray will is origin from the axis of the system, or where it is at the center of the system, and will pass through the edge of your aperture stop. Okay. And chief ray, what happens to chief ray? Chief ray is originating from the edge of the aperture, edge of your system, and it is passes through the center of your aperture stop. Correct? And which is the most appropriate answer here? Which is the most appropriate answer is that it passes through the center of the aperture stop, because the chief ray is defined like that way. It starts from the edge of the object and it passes through the center of the aperture stop. Okay. Okay. Any doubt? Next, a photograph has a brighter central region and dark edges. Which of the following is or are true in this case? So you can see that these are like a square option. Square options means there can be more than one answer. So you cannot, if you just to find out an answer, just don't stop that one. You have to see that, okay, there can be more answer. Okay, so tick boxes. Will we plug there? Huh?
Yes.
Okay. Okay, only you are there. No, for Florence. Okay, one is screen. Okay. Okay, which is actually the answer? It's already sir Mada explained.
Second and third.
Yeah. Second one is the one which is called effect is the photograph is called vignetting. Why it is coming like that way? Why vignette is coming?
Because of edge distortion.
Because the more light is actually coming from the central portion of your image or the object, because but the amount of light which is coming through the edge of the image is much less compared with your central portion of your image. So the edge portion is actually getting less intense, or I can say less intense compared with your middle portion of your object. So that portion will be like a somewhat darker. And how you can change that vignetting? By changing the size of the aperture stop, you can change the vignetting effect.
Sir, why the option first is not the answer?
Photograph has a darker edge since the image is out of focus even through the central region is at focus. Whether any out of focus happening there? Just think that I just think that there is a lens, and I have a lens. Let me clear some aperture here. So I have an image. something like that. Now it is forming a image here. This is my photographic plate. And this I am saying that okay, this is forming an image of something. Now see, now light is coming from here also, light is coming from here also. This actually passes through this way, and somehow it just passes through this focus and forming an image here. Okay, here anywhere it is a out of focus thing is happening here. So everything is got focused, everything is got image here, but the thing is that your central portion, this is like a central portion has a very high chance that to get more images is coming from your central portion, but your outside portions, just let it be your
So that means out of focus occurs only when there is coma, aberration, or is there any other possibility?
yeah. That will come later. Aberration can come later. But this is what happens in the case of vignetting. What you are going to see, you are going to see some image will be there. There will not be any clarity difference between this your images, because everything will be in focus only. But the thing is that your edge portion will be somewhat darker. There will not be so much light will not be there. This will not be so much light will be there. So similar way, something like this way. This all edge portion will have some more darker. It's not like a some black mark. It's like a less light will be there at the edge portion. Why? Because there is not much light is coming at that point. That's why. That you can change by changing the size of your aperture stop. Okay.
Okay, sir. Sir, we can change the dia of aperture,
Uh,
and we can also use it in a positive way in filming sector. Is it a benefit part?
Positive means
This vegeting phenomena
uh,
is utilizable in film where we have to focus some point and we don't focus the other areas,
yeah.
or it's a distortion.
It is not at all distortion. The bignative portion is not a distortion, and the thing is that you can use, because if you want to show some particular thing, it is looking like that particular thing will be, what you will do, you will arrange that position of your imaging system such that your main thing will be at the center portion, such that that will have a brighter area, and your attention will go towards that one. That is one thing. And the side portion will be some more darker, so your attention will be always towards your center. But you can see in some movies something like that way, you can see that in the movie things, you can see that your main frame will be in a very sharp thing, and your background is completely blurred.
Okay.
That is
So,
not a vignetting.
okay.
That is actually coming because of water. That also is completed. That also arranged by this aperture only. That is because of your field of view. Because if you are using a bigger aperture, you will have a not field of view, depth of focus. Depth of focus as well as your depth of field.
Okay.
Yeah, if you are using a big aperture, your depth of field will be less. So what will happen? Only the portion which is coming near your focal area will be focused, and all other background which have a little bit out of depth, not in the same plane. A plane which is a little bit away or nearby position will be out of focus. and that portion, so you will see that it's a blurred thing. So your main portion will be clearly focused, other background will be blurred. That is actually coming because of your depth of field thing. That also controlled by aperture stop, and this is actually how it is coming. It will be look like a plane only, everything will be in focus, but your edge of the frame will be somewhat darker compared to the middle portion of the frame. That is called vignetting.
Okay.
Yeah. Mm. Now that's okay. Effect of photography vignetting. Which of the following is true statement for a lens with a smaller f number? What is meant by smaller f number?
FL by D.
Yeah. And what will be the diameter of that one? So bigger or smaller?
It will be bigger. It will be reciprocal.
Yeah. So a smaller f number will be big diameter lens, or a big diameter aperture stop, I can say, or a larger f number lens will be smaller. So what will be the effect? It is a slower lens. Is whether it will be a slower lens? Slower lens means what? The shutter speed will be slower. That's mean by slower lens. Whether it will be a faster lens or slower lens. If your lens diameter is bigger, whether more light will come or less light will come.
Pardon, sir?
But
Please repeat.
I didn't hear. If the diameter of your lens or that aperture is bigger, whether more light will pass through that one or less light will pass through that one.
More light.
Yeah, if more light will coming from that lens, means that particular system, whether you want more time to expose your film or detector.
Less time.
Yeah, so whether which will be faster, big diameter will be faster, so it required very less time to process only.
Yes.
So that will be a fast lens. The smaller f number means it will be a fast lens. Okay.
Okay.
Yeah. Now you see, it has a smaller depth of focus or it will have a larger depth of focus.
Small depth of focus.
It will have a smaller depth of focus. How you will define depth of focus? Now just see that you have a lens. You have a lens and you are producing an image of a something, some tree or something. Now I am saying that this is producing an image here. Okay. What is mean by the depth of focus? The thing is that just think that this is producing an image here. Okay. So if your camera or focal plane is exactly here, it will produce a clear image. Okay. Okay.
Yes.
Yeah. But for us to see the image, if it's a little bit here also or little bit here also, the image will be almost the same clarity only. In the practical
Okay.
case, just think that if it is a little bit here also, it will be of the same clarity. You can see that that small portion. So this distance is called depth of focus. Now just think that if I am putting here, it's actually the lens is the aperture stop. Now I am putting another aperture stop here. So what will happen? Light will come from here and it will form. It will also focus through this way. Light come here. It will focus through this way. Now see, this much thing I could have covered. So the same distance to get it. Now I can go this much distance. See,
Yes.
so here depth of focus is more. So you see, when I decrease the aperture stop, what happened? Depth of
Depth of
focus
focus increase.
increased. So what happens? It has a greater, smaller depth of focus is wrong. Sorry, it has a smaller depth of focus only. That's the correct thing. So aperture has a bigger, small f number means a higher diameter, and it will have a smaller depth of focus. Okay, so
Yes.
it needs a
Because it inverses now.
yes. So it needs a short exposure time. So it is a fast lens. It will be a faster lens. So it required a short exposure time.
Yes.
Now, which of the following is are true statements considering the parameter of f number of a lens? Photographers always prefer to use faster lens than slower lens. Whether it is correct or not? Photographer always prefer to use faster lens than slower lens. Whether that is correct or not?
Yes.
Yes or not? Okay. Just think that
Maybe, maybe not.
ah
Because he wants a perfect image. In that time, he'll take more, uh, you know, time so that more aperture area is there, more light is there, and
yeah,
then the image formation is perfect
yeah.
according to that.
In the mobile also you may have take them photo. Sometimes you may use the macro thing, or you may use the landscape mode. What they are doing actually in the landscape mode, it will give all the things on your background in a focus such that you will see everything. But if you are taking like a selfie or very near portrait or something, what you will use, you want to see only your face, or the close-up thing should be clear, background should be blurred. So it depends on your like, or depends on your work, it can change. So you cannot say that a photographer always prefer to use faster lens than slower lens. It depends on the image what they want, it will change. So that answer is not at all correct. If a photographer tries to capture image of a football player during a match, he suggests to use a lens with a small f number. That's correct or not?
Sir, I don't know an explanation of this.
Now you see, there is a football match is going on. The photographer want to focus on a particular player. So what he want, the particular player should be in focus and the background should be blurred. They don't want to see all the things together. You want to see the particular player should be much more visible than other people. So what kind of lens you should use? Some big diameter lens should be used. that
Yes.
that we see now, this depth of focus, and the same thing the ulta it will come like a depth of field. So
Okay.
means a bigger dia lens he has to use.
Uh,
That means
Using bigger dia, he can capture more depth of focus.
less depth of focus actually. less
Less.
uh, Less depth of focus means only small portion will be focused, the background will be blurred.
Okay.
Yeah. More depth of focus means everything will be in focus. So you will see everything as together, like you are taking some scenery kind of thing, but you don't
Okay.
want that one.
Okay.
So you want a less depth of focus. So
Less data.
less
Okay.
depth of focus means a bigger,
Smaller f number.
smaller f number or bigger dial.
Bigger dias, smaller f.
Yeah. For a live cell imaging, lenses with a higher f number is preferred.
No idea. Live cell imaging.
Okay. The problem is that one, if you are
Yes.
seeing a live cell, actually you want to see a particular portion very highly magnified.
Okay.
So if you put a higher f number, what will happen? The amount of light collecting will be very less. Everything will be in focus, but the
Yes, yes, yes.
amount of light collecting will be very less. So
Similar case of football player
yeah, it's actually yeah similar case of football player itself.
because we focus something in
Ah,
particular.
yeah. So same thing. That's how that will not come through. Now a CCTV camera is placed on a top of the door. So what you want? Higher f number or small f number?
In this case, we want everything to focus, so we will take more dia and
No,
F number will be.
actually it's opposite. Whatever you start,
We will take more depth of focus,
yeah,
so dia will decrease
yeah,
and F number will reverse.
yeah. So die will be decreased, f number will be higher.
Yes.
So that's correct. So this is the way you have to do. You have any doubt
Uh,
regarding this Oslo things or something?
n- no, sir. Can you please tell? I tried to operate, but I was not able to put the values in BAME radius when I tried.
Okay. If you want, I can show that also.
Sir, please, if you can.
Yeah. Now we see what is the question. You have to model a plane of convex lens of radius of curvature R1. So I'm going for Oslo. Ninth question you just see. What is PU operand?
Yes, sir.
This is direct. It's a direct question.
This is right.
Yeah,
I want 10th one.
yeah. Now you see. You want to model a plane of convex lens of radius of curvature R1 is equal to 550 centimeter. Okay. So I am going for Oslo. You are seeing my
Yes, sir.
window, na? I'm going to start a new lens. I'm going to put some extra after and that told beam radius of
Beam radius
okay you can tell if you can see that one you can tell
5 mm.
beam radius of 5 mm field angle
Uh, Field angle 30 degree.
30 degree and there's a curvature
Um,
50
Curvature 50
yeah
radius curvature.
diameter anything they mentioned or thickness they mentioned anything
Thickness of surface 110 mm.
and surface 2 or something
Surface 210 mm.
10 mm
AST to be 30 mm.
okay and surface 3 is the aperture stop they
Decline.
mentioned this I think that so
They have written AST. Sir,
uh,
what is AST?
this is aperture stop they are saying aperture stop and it is getting after solved that's the thing now you can
Okay.
I'm saying that I'm putting them a third surface as a aperture stop so you can right click and select that one see aperture stop now that first mm is change it to this one. Now I will change that BK7.
Yes.
Okay, now put draw. Now you got a lens.
Yes.
Okay, now the question is like that way. What's the question? You have to change the,
Make surface 3 as aperture stop.
yeah, that I already made. You can see
Yes.
surface 3 is the aperture stop.
Stop.
Yeah. Now,
What is the value of radius of curvature of surface 1 after optimization?
okay. You want to optimize in such a way that your focal length is 75 or something, I'm thinking.
No. Answer is 75. No, no. Optimize effective focal length to be 75 using radius of curvature of surface 1 as
As variable.
variable.
Okay. Optimize the effective focal length to be 75 mm using the radius of curvature of surface 1 as variable. Now you see. Now, which is the radius of curvature? 50. So,
Yes.
now what is your focal length? Whether you can see easily from here in this.
Can you increase? Oh, once.
Okay. Here you are not seeing. Or
No, yes, I can see.
here also you can see. What is the focal length? It's written.
Focal 96.75.
Now I'm just changing this one. 50. I'm changing to some 60.
Okay.
Now what is the focal length?
116.1.
116. So you can say that okay, it should not be 60. It should be some 45. Now it is
Okay.
changed to 87.
87.
So you can play with this thing and you can attain a value of focal length of 87.
Okay.
But that is not going to be a good idea. Okay.
Okay.
So what you want? Now you want to change the radius such that your focal length is to be
75.
75. So I want to change that one. So right click there and consider it as a variable.
Okay.
Now this is a variable thing. Now I am going to optimize. Okay. Now I put it as variable. See.
Yes.
Now I am going to my optimize. Now optimize here and go for aberration operands.
Operands.
Now we see whether anything is there corresponding to your focal length. You will see the last 21 things.
EPM, effective focal length.
Yeah. So give that one a weightage of 1. So
75.
you want actually what they are giving, they are checking the error.
Okay.
So if you want a focal length of 75 and you already have a focal length of 75, what will be the error?
0.
0. So now you have a focal length of 96
Yes.
and you have a you want a focal length of 75. So there will be some big error will be there. 96 minus 75 will be error.
Yes.
So in this case, actually this software will try to minimize the error. So
Yes.
so you have to give a weightage of 1 where you want to change it or Oslo should be calculated. You already defined as it as variable. Now we give a weightage of 1 here. Now this OCM 21 is the one which is actually the focal length they calculated now. Now you want to minimize the error such that when it is coming to 75, it should be become 0. So what you
Okay.
do? You put an error function of OCM 21 minus 75. Okay. So this now what is Oslo will do? They will find out this value OCM 21 minus 75. It will continuously calculate and try to minimize this one to 0, considering your radius of curvature as a variable. Okay.
Variable.
So I am putting yes. Now you put here. Now there's an option of iterate.
Yes.
Go for iteration. Press that one. Now you see that it's a continuous error, and each time it is calculated. First it was some 96 na.
Yes.
96 that time error was if 75 then the error will be some 21.
21.
Then next again it is changed your radius of curvature, they changed it and again they calculated the error changed to 3.97. Then again they iterated, they calculated it is like a 0.18, then
Okay.
0.00323, then it is iterated, it is become 2.4862 into 10 raised to minus 7. Now 1.9247 10 raised to minus 10.
Yes.
Then it's like a error is very less, so but it is consistently going, then they stopped the iteration.
Yes.
Now you see what is your beam radius or that radius of curvature.
Radius 38.76.
Yeah, now you see what is your answer. 38.74 something. See.
Okay.
Okay, this is the
Yes.
way it should do. Okay.
Okay, sir.
Yeah. Okay, so if you have any doubt you can put it in your group the question such that I will be checking.
Sir, from where I can check the group?
Means I'm saying about that you have that this one na feedback thing and other things where you can post it in this here. Here you can ask question.
Okay.
Yeah, somebody asked something. Yeah, can we get solution? Okay. Still have problems of this. Yes, I think so.
Okay.
So if you have doubt there, just put there. Okay. Hopefully you can get the answer. If any doubt is there, you can just put it there and we'll clear next session.
Okay, sir.
Yeah.
Uh, thank you, sir. Sir, you are from?
I'm from IIT Madras.
Okay.
I'm also a PhD student only.
Okay. Thank you, sir. Your
Okay.
name, sir?
Mine is Jijit. JL.
Yes, is it?
Okay.
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 Thank you, sir.
Thank you.